Have you ever pondered the thought that our reality might be someone's daydream? Is it conceivable that every thought, emotion, and action we experience may be influenced by a higher power? The concept of a simulated reality is not a novel one. It has captivated philosophers, filmmakers, and even scientists for centuries. Essentially, it proposes that what we perceive as reality is a meticulously crafted virtual world created by an exceedingly advanced civilization or entity. In this scenario, we are characters in a cosmic video game, entirely oblivious to the true nature of our existence. Let's delve deeper into this idea by examining two intriguing images. On the left, we observe intricate brain cells, while on the right, we encounter a map of the universe known as the cosmic web. When you look at both of them, they appear remarkably similar. However, before we begin speculating about a cosmic connection, there is a simpler explanation. The immutable laws of physics govern both the minuscule realm of brain cells and the vast expanse of the universe. Two astrophysicists worked on comparing the two entirely distinct systems, the cosmic web and the network of brain cells, and they unearthed something astonishing. Despite one being massive and the other minuscule, their research revealed that both systems could give rise to similar complex structures. So what is the significance of this discovery? Well, their findings underscore that both the cosmic web and the human brain exhibit an extraordinary degree of complexity. Whether we contemplate the boundless cosmos or the workings of our minds, they share this complexity. Could there be universal principles governing both the universe and our thoughts? Is it conceivable that we are interconnected with the universe, constructed from the same intricate elements? As we dig deeper into the worlds of astrophysics and neurosurgery, one thing becomes abundantly clear. The universe resembles a vast tapestry woven with interconnected threads. Whether we gaze upon the cosmic web or contemplate our thoughts, they both manifest as complex and self-organized systems. In the grand web of the cosmos, where galaxies twirl and DNA coils, a captivating symmetry has captured the attention of scientists and philosophers alike. DNA, the blueprint of life, and spiral galaxies, those majestic stellar formations, both exhibit a spiraled form. DNA, the architect of our genetic code, consists of two elegant strands entwined around each other, forming the iconic double helix. In the depths of space, spiral galaxies boast their graceful swirls, with arms curving around a central core. It's as though they engaged in a cosmic dance, prompting us to ponder the intriguing resemblance. Why do these two entities, one minute and intimately tied to life, and the other colossal and a part of the universe, share such a striking likeness? The answer remains a massive mystery. However, this similarity suggests an underlying order and harmony in nature that transcends our current comprehension. With these shared characteristics in mind, scientists embarked on a quest to uncover the hidden connections between these phenomena. They conducted computer simulations to study how galaxies are interconnected and juxtapose this with the intricacies of brain regions responsible for cognitive processes. Their objective was to decipher how patterns emerge across vastly different scales, from the cosmic expanse to the microcosm of our thoughts. They also delved into mathematical analysis to understand factors such as the number of connections each point possesses and whether these connections converge at a central hub. Their findings proved to be astonishing. The numerical values and patterns in these intricate networks exhibited remarkable similarities. This revelation challenges the notion that galaxies and brain cells are fundamentally dissimilar. Throughout history, humanity has striven to decipher the fundamental laws that govern the cosmos. From the tiniest subatomic particles to the grandest galaxies, they all adhere to the same laws of physics. However, despite these shared principles, the outcomes can be vastly diverse. The stunning patterns we observe in the cosmic web emerge due to factors such as gravity, the enigmatic dark matter that eludes our understanding, and monumental events like supernova. These elements contribute to the captivating designs we admire through telescopes. In contrast, our brains have evolved over billions of years. Unlike galaxies, our brains were not shaped by cosmic phenomena, but transformed gradually over time as each generation passed down traits that facilitated survival. Our brains exhibit a specialized organization, with neurons strategically placed to transmit information rapidly. This trait is an inheritance from our ancestors, who relied on quick thinking to evade perilous predators like tigers. Today, we apply that rapid thinking to navigate academic challenges rather than predatory threats. In the vast cosmic space and the intricate workings of our minds, there exists a profound connection that transcends our current understanding of the universe and our brains. This connection revolves around the shared network structure that characterizes both systems, a network composed of nodes, lines, voids, and clusters. Picture an expanse network composed of billions of nodes interconnected by lines. In one realm, these nodes take the form of neurons, the fundamental components of our brains. They communicate with one another through electrical and chemical signals, shaping our thoughts and emotions. In another realm, these nodes manifest as galaxies, colossal entities in the cosmos held together by formidable forces such as gravity and electromagnetism. The filaments that traverse these networks are equally intriguing. In our brains, they are referred to as axons, and they're responsible for conveying crucial information between neurons to facilitate rapid and precise communication. In the cosmic realm, these lines are akin to dark matter, an enigmatic force binding galaxies together and orchestrating the celestial ballet. Clusters emerge in both domains, whether as groups of neurons in our brains processing information, or galaxies congregating in vast cosmic neighborhoods. This is similar to the vacant spaces that separate different active regions within our brains. The cosmos features regions with fewer galaxies. However, this connection extends beyond mere structure. Both our brains and the universe exhibit a fascinating mathematical concept known as fractals. These are patterns that repeat regardless of the scale at which you examine them. The branching of rivers, the intricate designs of snowflakes, and even the twinkling city lights seen from space all display this fractal nature. While neither our brains nor the universe are perfect fractals, they come remarkably close. This connection to fractals is not accidental. It hints at an underlying order and complexity that unites these disparate systems. Beneath the shared shapes lies an even more intriguing parallel. They both function in remarkably similar ways. Both our brains and the universe are profoundly interconnected. They abound with pathways and links, facilitating the seamless exchange of information, the blending of elements and adaptability to change. This interconnectedness also lends them resilience in the face of damage or alterations. They both possess a hierarchical structure, with similar components combining to form more intricate entities. This organizational approach enables them to perform multiple functions concurrently, adapt to novel circumstances, and evolve. Another common trait they share is perpetual motion. They respond to internal and external stimuli, never remaining static. This attribute imbues them with a sense of history, memory, creativity, and an inexhaustible capacity to generate new ideas and phenomena. In our brain's network, the densest and sparsest regions are precisely 100 times apart, spanning from 1 micrometer to 100 micrometers. Remarkably, the cosmic web exhibits the same behavior, with dense and less dense regions differing by a factor of 100, stretching from 5 million light-years to 500 million light-years. Such a degree of similarity is exceedingly rare in the natural world and underscores the profound connection between these web-like structures. Researchers have also researched about the synaptic connections between neurons in our brains and compared them to the intricate connectivity within the cosmic web. What they have uncovered challenges our understanding of both information processing and the cosmos. Each brain cell extends approximately 4 to 5 axons from its central point, while within the cosmic web, roughly 4 galaxies are tethered to each central point. However, the similarity doesn't end there. If we were to envision using the entire cosmic web for data storage, it could accommodate an astonishing 4.3 petabytes of information. Now, when we compare this with the human brain, renowned for its complexity as an information processor, it theoretically processes the capacity to store about 2.5 petabytes of information. At first glance, the difference between 4.3 and 2.5 petabytes might appear substantial. Nevertheless, it is essential to recognize that even slight alterations in the neural network structure can result in significant disparities in storage capacity. Consequently, the proximity of 2.5 petabytes in the brain and 4.3 petabytes in the universe is a surprising revelation. It is almost as if the cosmic web is impeccably suited to serve as a repository for the colossal volumes of information that sentient beings like humans could accumulate throughout their lifetimes. Intriguingly, the brain consists of approximately 77% water content, while dark energy constitutes around 70% of the universe's mass. Consider the evolution of the internet, a vast network with nodes represented by devices such as computers and smartphones. These devices, similar to the nerve cells in our brains, incessantly exchange and transmit information. Yet, does the internet possess consciousness? Presently, the answer is a resounding no. The devices comprising the network are still far from meeting the criteria for intelligence. However, as artificial intelligence continues to advance, and these nodal devices become more intelligent, the internet might undergo evolution, conceivably acquiring a form of consciousness akin to our own. This concept may appear audacious, but the possibilities it presents are as intriguing as they are boundless. Much like our brain forges new connections as we encounter new experiences, the universe evolves in its unique manner. Stars are born and extinguished, galaxies collide, and new worlds emerge. Nonetheless, we must not overlook the fact that mysteries still envelop us. The inner workings of the brain remain a subject of ongoing exploration, ridden with unanswered questions. Simultaneously, the universe, with its profound intricacies, continues to capture our imagination. And that's it for this video. If you want to see more videos like this, click on the cards on the screen. And as always, keep exploring.